Okay, so here we go again. So today we're going to talk more about sets, and again I'm going to introduce a lot of terminology, and so it's important. This is going to be important for the rest of for college algebra, because this is kind of like the underpinning of what we do in college algebra, dealing with sets and set notation and understanding the relationships between sets of objects, and in this case numbers. So here's some more operations. So we're going to talk about operations between sets. Okay, one of the things is the complement. Okay, so the complement of a set. Well, and the complement of a set, and I'm going to say this in words, is if I have a set A and I want the complement of the set A, then what I want is I want all of the elements that are in the universe that we're talking about, but are not in A. So let me say that again. The complement of A are all of the elements that are in the universe, but not in A. That's the complement of A. What we denote, and how we denote that, is by using the symbol, let's say, A prime. Okay? So with a little slash here, we call that a prime. So we pronounce this A prime. So A prime is the complement of A. Okay? Some textbooks use A bar for the same thing. But again, this textbook, or whatever textbook you're using, might use A prime. So I'm going to use A prime, but realize A bar is sometimes used. Oh, some textbooks use this. I've seen it use this with a little C at the top. And so for complement, okay? So again, you'll see different symbols depending on the textbook, okay? So I'm going to use A prime. That's probably the more common way of seeing it. So the complement of A, it means that all elements in the universe, but not in A. Okay? Now, the intersection, when we talk about the intersection between sets or among sets, we're talking about all the elements that are in both or all the sets. So it's like an and statement. So if I want the intersection between set A and set B, then what I want is I want all the elements that are in both A and in B. So in the intersection, we use this symbol. So we use the symbol of an upside down U for intersection. Okay, so we would write, if we wanted the intersection between sets A and B, we would write it this way, which means that we want only the elements that are in both A and in B. And another way to write this as a Venn diagram, if you want to visually see this, is we would have A and B, right? And then the intersection oops, not very good. That's not. Is that. So the piece where it overlaps represents the intersection. Okay? Now, disjoint. Well, what does disjoint mean? Disjoint means that there is no intersection. So if we have two disjoint sets, there's no overlap. That's what disjoint means, right? Two disjointing circles are circles that do not overlap. Or what we call mutually exclusive. That's another term that will come up in other classes where we deal with sets, like, for example, statistics or probability. So another word to be familiar with is mutually exclusive. and we're not talking about dating. So we're talking about sets. So disjoint sets, right, are sets that do not have anything in common. So we would say if two sets are disjoint, then we would say that A intersect B is equal to the empty set, right? And visually, with a Venn diagram, we would represent it this way. Okay, so those are two disjoint sets. That's what disjoint means. Okay, now union. Union is another operation that you're going to want to be familiar with. Union means that I want all the elements that are either in A or in B or both. So it goes farther than just the intersection. So where the intersection is an and, the union is or, and it's an inclusive or, which means it could be both. So I want all the elements that are in just A, or the elements in just B, or both. So I want everything. So union means I'm combining everything. I want it all and get rid of the duplicates. That's what union means, right? The union means to bring things together, right? So if I want the union of two sets or three sets, I want to pull them all together, dump them in the same bucket, and get rid of all the duplicates. That's what union means. Okay? So, how do we depict that? What symbol? Well, the symbol that we use for union is the U. Okay? Not to be confused with the universal set. The universal set is a capital U. This is a symbol that looks like a U, and you'll see what I mean. It's like a curved horseshoe. Okay? Very similar to the subset, the proper subset symbol. So again, but it's vertical. Okay? So we use this symbol for union, and so if we wanted to say, hey, I want the union of A and B, well, in a Venn diagram, it would look like this. So oops. Okay, so what would it look like if I wanted the union of A and B? Well, another dead one. Man, I'm running out of markers. Let's do this one. So that's the union of A and B. Okay? Now, what about the complement? Let's go back to the complement. Let's say I have this one. Let's just do this one. And I say, I want the complement of A. So how would I represent the complement of A in this case here? The complement of A would be, again, remember, complement of A means everything that's in the universe but not in A. Well, that would mean everything outside of A is what I want. So how would I represent it with the Venn diagram? Well, A complement in this case would be oops. Oop. Yeah, so everything except A. is the complement. So basically, A prime is everything in green. And that's it. So the next few videos, we're going to start just doing examples. Okay? So that's it. Have a great day.